Thanks, everybody. Thank you for joining, and thanks for taking time out of your busy schedules to spend time with Cubro this morning. As you can see from the screen, the focus of the webinar this morning is to describe and discuss how a network visibility architecture, really, or infrastructure based on network taps and packet brokers can strengthen the operational technology or security and performance of operational technology networks. My name's Paul Brett. I'm your host today. I'm actually responsible for Cubro's business in the UK, Ireland, and Middle East. And I'm joined by Herbert Ettlinger, who's actually one of the founders of Cubro and is responsible for both our pre-sales and post-sales technical teams. The agenda today, I'll just do obviously a short introduction, and then I'll just talk briefly in a second about just to highlight the value of our OT solution set. But actually, the bulk of the webinar today will be carried out by Herbert, really describing obviously what the background is to OT, what the key challenges are, and therefore how Cubro technology can help with the security and performance of those environments. And I'll come back in the end with a summary. We'll have a Q&A at the end of the webinar today, but obviously feel free to flag up any questions that you have as we go. We can address those when we get to the Q&A session. We'll also have some handouts today and some poll questions. So obviously would appreciate your participation in those to provide some very useful feedback for us for future webinars. So I think then we're probably all set. So if I move into that first part, then what's the value of the Cubro operational technology solution? So I guess just to baseline that, what we see as operational technology systems are hardware and software systems that monitor and control industrial type processes such as utilities, so water, gas, electricity, and the like, manufacturing, across a wide range of different environments, of course, energy production and transport. So it's fairly straightforward. And of course, what our solutions is able to do is to enhance the efficiency and effectiveness of those systems by maximizing and improving their security and their performance. So by applying our technology, really the three high level values typically that our customers enjoy is we can help to improve business and organizational performance. And we do that actually by being able to help increase the revenue and profitability of those organizations, which is sort of linked into that second point, because of the technology we can deploy helps to improve the reliability and availability of operational technology operations. So less outages, less downtime, less problems, either caused through security compromises or through performance problems. We can help to achieve and maintain regulatory compliance. That's very important in operational technology environments. We can help to reduce the risk of production outages, which also obviously then relates to things like reducing the risk of reputational damage. So all of those things combined help to improve the performance of the business and the organization. The second sort of high level value that our solutions are able to deliver is to improve worker safety. And we do that by reducing the risk of equipment failure and or damage, because again, better management of those operational technology processes helps to reduce the risk of things going wrong. And finally, we can help to protect the environment, because again, related to that, we can help to reduce the risk of leakage of toxic substances, in certain environments, certain manufacturing processes. So again, reducing the risk of there being problems with technology, problems with those substances, and allowing them to leak out into the local environment. So those are, I guess, as a very brief sort of introduction and high level, those are the high level values that Cubro solutions applied to operational technology environments can deliver. And now I'll hand over to Herbert, who will take you through the detail of, again, what those environments look like, what the challenges are, and therefore what the Cubro solutions are able to deliver. Herbert, over to you.
Yes. Okay. Thanks, Paul. Yes. So this is Herbert here. All right. Thanks, Paul, for the introduction. Um, right. Look, now is my part, and let me start with sharing my screen so that you also see something what we are talking about. So it should be there, I think. Right. Look, the now this part of the presentation is, of course, we will just a little bit explore. Let me go to agenda first. Is, of course, we need to talk a little bit about the what means OT, what means network security in terms of OT, also what benefits you would have from network monitoring, and then also talking about the infrastructure that could deliver the traffic to monitoring tools to improve securities. This is like we are talking about network taps, and also of course some words about network packet brokers for these applications. Good. So far to the agenda. Yes, let us first just a few minutes spend on OT. And the first question is very often people asking, hey, what is the difference between OT, operational technology, and IT? And basically, as Paul already said, is OT deals with industrial processes, with hardware, with software that is used for manufacturing, energy, transportation. So all these kind of critical infrastructure. And IT, on the other hand, is dealing more about computing, yeah, about the data itself, how to make them secure, and managing information within organizations. That's the general difference of it. And basically, people always thinking that OT is something new. No, OT is not new. Of course, it's existing for many, many years. Of course, manufacturing and all these automated processes. Now, of course, but now we have some new challenges in the recent years. We will come to that. And in traditional thinking, OT and IT were kind of separated. There was an OT network and there was an IT network. As we said, IT handles the critical data processing. It supports the business applications and users. OT, on the other hand, is for the industrial production and process control systems. And usually, as we said, there is an air gap between these two worlds. That has been true, but in recent years, that has been changed. And now what we are seeing is this convergence. Convergence means that now there's an integration of both worlds. That means there's a real-time data exchange between these worlds. There's interfaces that things they are talking together. So being seen as more as one network. That has a lot of benefits, of course, but there's also certain threats, which maybe did not play a role in the 60s, in the 70s, or in the 80s, or in the 90s. But now, yes, now because of combining these two worlds, there's new challenges to be mastered. And now let's think why security is important in an OT network. And this is just a recap of what Paul said. There are a lot of things we have to consider. Of course, it's about safety for human life, of course. It's for the environment. But of course, it could really be also financial losses. So if production goes down somewhere, yes, that has a direct influence. Of course, is also for reputation, and also it's the compliance to regulations. Okay, so there's a lot of things we have to consider. It's not like, okay, if the car manufacturing plant stops, yes, that's a huge loss, like any other industry. Okay, so what are the ways, of course, what are the ways to improve network security in an OT network? And just, of course, there's millions of papers available, and there's many things you can do, you might need to do, and this is just a short summary and some examples only. There are people talking here about network segmentation. This means to segment your networks in different areas and to keep them somehow isolated from other segments. So kind of network organization. Of course, we're talking about firewalls or access control. We are talking about backup and recovery in case of disaster. So, and there's different things that play a role also for OT. So things that maybe are well known in IT now also migrate to the OT network. And also what we've seen in IT already is there is network monitoring, anomaly detection, just to monitor the network to find if something goes wrong and to detect intrusion and things like this. So this also starts to play a role. And there's just one slide about some examples, and this is just some examples. And looking at that, started, I mean, first time, and this really becomes very, how to say, in the media, public, was when you remember 2010 Stuxnet, when this was disrupting the Iranian nuclear program. I mean, this will actually we will have some conclusion for these kind of things. But there's also others, yeah, for New York, these floodgates, and so on and so on. So there's really critical issues. Also, some years ago, we had the similar issue in Austria for the company who was producing milk and cheese that they had for 10 days, they had to stop production. So that's dramatic loss. Yeah. Nobody will be killed, of course, if there is no milk. But anyway, yeah, so it's for the business itself that plays really dramatic role. And there's really many, many examples. It doesn't matter if it's car manufacturing or if it's power grid and things like this. Yeah. Or even you see here for the medicine production companies. So there is many examples, and these are just the ones that are really known and public. Okay, so there are, I think, most likely many, many others. Okay, and the lessons learned from these incidents is that in OT networks in general, because of the history and they have been separated, is there's a lower focus on security itself. Okay. Also important is that now we are not talking about that some hackers and they have some fun and this destroy something. Yes, that's also bad. But now this is actually things that are done by nations. Yeah, so it's a kind of also kind of war we have to take it into account. And also these attackers, they are rising expertise. So there's more and more of these, of course, yeah. And they are concentrating on OT because this is something that hurts, of course. So if if the web page is not working anymore, yes, that's very bad, of course. But of course, it's even worse when you hack some manufacturing. And what has been this common attack is, yes, there's some ransomware, there's phishing, malware, internal threats, of course, and so on and so on. So there's many of these things that IT people are well aware or should be aware. Yes, they also find their way to the OT. So now but what could network traffic monitoring do for us? I mean, why this is important? And network monitoring actually, in fact, what it does is it gives us real-time visibility of seeing what is going on in a network. It actually let you discover the assets. That means who is on the network and what connections are live, what communication is going on in a network, what protocols are used. This is actually what network monitoring does for us. So actually it gives us a good or very good overview or even in-depth knowledge of what is going on inside a network. And usually when talking about OT security usually begins with knowing your assets. And just get a complete picture of your network and applications running to see what protocols we have, to see the devices using maybe unsecure protocols. Maybe there's telnet in use, which is not safe, and things like this. That is actually what network monitoring gives to us. And of course, and it allows to make informed decisions. So knowing what is going on, who is talking with whom, maybe even over time, if you look at the traffic pattern, communication, let's say, map, then you would also recognize if something is changing. And this change, maybe it's because of something happens. And then knowing this would allow you to make an informed decision and to gain in-depth insight what is really going on. Okay, so this is actually what the monitoring gives you. Network monitoring is actually that tells us reality. So what is really there? The problem is, I mean, there's some security tools available for OT networks. There's manufacturers, they give you tools that let you allow the traffic. The only question now is when you have network, okay, complex network with manufacturing, with telephones, security cameras, servers, switches, whatever, how the traffic that is inside here, how you can actually feed to the analyzer. That's actually usually that's the challenge. And this is the question we try to explore now in the second part. And so how to access the traffic. And of course, now let us start with some very basics is about, of course, these to connect devices in a network. What is usually used is an Ethernet switch. An Ethernet switch, what it does, very easy, plug and play. It connects, in our case, A and B. Okay, so A and B can communicate. And if this is a C, then C can communicate with D or also with A. So, right, this is the switch. This is the purpose of the switch. But what happens now? You're coming with your monitoring tool. And if you connect your monitoring tool to the Ethernet switch, of course, the monitoring tool will not get this data that are running between A and B. Yeah, that's actually not the purpose of a switch. So it does not give you the copy of the traffic, except there's one function in a network switch is the so-called mirror session or spam port. Spam port actually stands for the switch port for analysis. And what the spam port does, actually, it delivers a copy of the traffic by a so-called mirror session. I mean, for me, this sounds wonderful. Wow, cool. So you get the traffic, and this is what you need, and then you can feed it out and analyze the traffic there. So perfectly okay, but there's several points we need now to consider. Is that of course a mirror session needs to be configured. So it needs some operator who sets up. It needs to define, of course, what is your ingress, what is your egress, what is your source port, what is your destination port. So it is needs some expert knowledge. Okay. Anyway, this somebody could learn. This is maybe not so important, but is some efforts. But there's some other points to be considered. Doing this means, right, very attractive, as we said, is this is a software-based feature of the switch, if available. Not every switch can do that. Maybe it's a software license that has to be bought anyway. But maybe it's a very cost-effective option. But never forget, there's a lot of limitations. And before coming to this limitation, I mean, just a short story is, I mean, we as Cubro, we are actually many years ago, then we have been selling monitoring equipment for telecom operators. We have won a project here in Austria, very nice for us at that time, with a third party supplier. And customer also said, yeah, we have spam ports. So from day number one, we have been depending on spam port. So when you are the monitoring tool, you always be dependent on somebody else. So if something is wrong on the monitoring, then you will say maybe the spam port is wrong. And what happened is that every day somebody changed the spanning port. So every day you have a problem in your monitoring system because you are not getting the traffic you need. Every day is discussions. Then other issue is that all of a sudden traffic is missing. Why is that? Because When you use active monitor, active spam port sessions, what happens is that you are using for the monitoring using the same hardware resource. So the switch is made for switching, of course. So it should connect the party A and B, let's say. It's not developed for spanning. Spanning is an add-on, but if something goes wrong in the switch or if there's overload situation, of course, traffic in the span port has the lowest priority. So yes, that will result in packet loss and blind spots. Plus, the problem is that there's always some reconfigurations, and these reconfigurations always will have issues on the monitoring side, to miss traffic, for example. Of course, it also has limitations. Okay, also very difficult sometimes to set up the things. Yeah, so it requires really expert knowledge, and as we said, also incorrect setup or overload situation will result in problems. Yeah, so that's actually the issue with spanning ports. There might be certain situations a span port is needed. That's out of question. We're not saying that span port is bad in every case, but whenever it can be avoided, it should be avoided. It's a potential troublemaker. Okay, so what is the alternative to spanning? Is a tap. What is a tap? Tap is a hardware device. Hardware device that gives you a one-to-one copy of a traffic that runs on a link. So what is a link? A link actually is a full duplex connection. So full duplex connection means you have an west side and east side, and there's a transmit to receive here, and there's transmit to receive here. That's actually called a link. And what a tap does, it gives you a copy of this traffic running from A to B and B to A. Okay, so link with a tab would look like this, and usually remember a tab always gives you two outputs because there's the traffic running from A to B is green, comes out here, from B to A comes out here. So actually here it gives two output ports. That's also important to say. Very often, of course, with a spam port, you could also set that up to give you both direction, becomes more and more complicated. Also, very often will happen, it will result in duplicated traffic. Okay, this is also some problem of spam port. Here, it's dedicated, it's a physical device. This is what the tap is. And the key points, of course, so we should never say it's only positive. Of course, it also has some costs. So it's an additional hardware you need. It's also some needs to be deployed. So there's some installation. But never forget, it's completely transparent. Transparent means it gives you a one-to-one copy. So there's no backplane, there's no CPU, there's no ASICs and things like this involved. Also, it gives you out wrong packets. Usually a switch, if there's a wrong packet, if the packet is no good with an FCS CRC error, it will just be destroyed. It will be discarded in the switch. Usually TAP doesn't do that. It also feeds out that. Of course, it's passive. Usually tap means it doesn't have any, setup to be done except a physical connection. There's no software running on it. Usually tap doesn't have any management interface at all. Of course, it's also very flexible because you can also connect it not only between switches, it can be routers, firewalls, or whatever device. Also important is it gives you an isolation. Isolation meaning that the monitoring is receiving the traffic, but cannot insert traffic in the network. So it's also kind of protection. So it's working like a data diode, let's say. Yeah. So it's unidirectional. Only traffic can be fed out, but not be inserted. Okay. Talking about the tabs, of course, there's different tabs. Basically there is optical tabs for optical links, and there's copper tabs for base T or copper links. Very evident, let's say. And optical tap, this is a very easy one, and that's the really a beauty, is a pure passive device. It's fully transparent, and how it works is you come in with light, let's say 100% of your light coming in the tap, some part, let's say 50%, you feed further on the live system, and and the other 50% you feed out to your monitoring. And that's it. It's completely transparent. It doesn't matter if the bit rate is 10 megabit, if it's 100 megabit gig, 100 gig, 400 gig, whatever. Yeah, it just deals with photons, okay, with optical photons, nothing else. The only thing that needs to be considered, of course, is because you're splitting the light, is there is insertion losses introduced. So the optical power itself is reduced. Of course, this is a question of optical budget calculation. And if somebody is interested in, there is endless material available about this topic. Okay, but basically, there is no electronics inside. It's just pure physics. And here's just a video of a connection of a tap. I will play this video and you can take a look. And maybe I will say something, but it just, yeah, right. So it starts that. And you see the, you see the connection now between a switch and a switch. You see full duplex. Okay, always never forget there's TX and RX, of course, and you see traffic is running. Now we come with a tap. You just take this cable from the switch, feed it through the tap, and then take the same cable again from the tap to the switch. And on the right side now, you see the monitoring. And what we see is this tap output is just an output. Yeah, there's only light is coming out. It's not going in, of course. Yeah. So if now wait a little bit, and you see this is the packets, let's say, the packets running through the tap, and at the same time, you can also feed it out. This is actually how the taps work. And there's no configuration, as we said, if of course doesn't have any electrical power or so. Okay, fully passive, transparent. Of course, as we said, there's a certain insertion loss. This insertion loss, yes, needs to be considered for the system planning. Yeah, but this is not rocket science, so to say. So let's talk about copper taps. In copper taps are more complex than fiber. Why is that? That's some internal drawing, let's say, how this tap look like, and you see some components. You see PHYs, so these are chipsets. You see relays, and things like this. So this is active, yeah. And basically, we have to need to consider if the link is a 10 megabit or 100 megabit, this live link, so this is actually here on top, you see the active link. So this is where the traffic is running, so productive traffic is running, is fully passive. That means if the tap fails, then this connection will not be interrupted at all. The only thing that will happen is that the monitoring will not work anymore. It's bad, but still you have the active link is running. But when we talk about gigabit is different because of the concept of gigabit. Is in gigabit what we need relays. Relays, these are there. If something goes wrong on the tap, what happens? These relays will close the active link so that the production network goes on. Okay, so, and depending, of course, on the setup and everything, there might be some interruption in live traffic if the tap would fail. This depends on several conditions. Maybe it goes too far into detail, but could be. It must not be, but it could be. Okay, so this is the difference. So but you see, of course, it's more complex than optical fiber tap. And yes, as I told you before, that actually, when continuing the story of this monitoring system we sold more than 20 years ago and had these issues with spam ports, then we had a lot of discussion about tapping, and that was actually the foundation of Cubro, where we said, hey, look, this with the spam port, this is not the future. So we are trying to build our own tabs, and that's actually a foundation. And of course, started with some optical tabs that you see here, and later on, of course, also continue with electrical tabs. Yeah, so of course there's different sizes, there's different port counts, how many links you need to tap. Yeah, there's different alternatives. Yeah. Okay, so that actually, this product you see here, the chassis here, this actually works with modules you can plug in. That actually is very popular in OT applications. Why is that? Because you can tap many links. Yeah? That's actually the background of that. Right, but let us go one step further, because what we said is, when you have tap, that means for every tapped link, every link, you require two ports on an analyzer. There's one port here and there's another port here. Okay, good. If it's one link only, maybe you can buy an analyzer with two ports. It is fine. Huh? But what happens if you're in the real world and saying, hey, I have traffic from spam ports coming, I have traffic coming from taps, I have maybe 20 links to tap. So 20 links tapping means 40 analyzer ports. Yeah, of course, the security tool vendor will love it. Yeah, can sell many boxes, but most likely it's not so cost effective. So what's the alternative now? How can we do that? And that is actually, we are coming to the next step, is the packet broker. And packet broker means this is a box, we'll see in a second, that actually delivers the information to the analyzer, to the probe, in the right format. In detail, it means it's like, you can maybe somehow imagine as a kind of switch. Okay, but it's dedicated hardware, first of all. And what it does is, it can accept traffic from many different sources, so from many different tabs, and then will organize this traffic. So certain parts of traffic go to maybe some analytic system one, others to two, whatever. Maybe some information you don't need at all, so it can be filtered out. Okay, this is what packet broker does. And uh, this is just for representation, so we don't need to go into details. So that is our packet broker range. There is many different products for many different requirements. So for example, if people only need base T ports, so copper ports, yes, we have. But of course, on the other hand, if somebody needs 400 gig, maybe this is for OT, is not so much the case. Of course, we also need. So there's different products for different requirements, and the major deciding factor is the number of ports, how many ports it has. Yeah. And of course, later on in this list, you also see some kind of functionality, but we will evaluate that. Okay, just as one view that you see what we are doing. And one very good example of what a network broker can do in OT is, when you have this scenario, many tapping points, mirror points is, but you only have one analyzer. And the analyzer has maybe only one port. Maybe it's 10 gig. And here you only have 1 gig. What we can do is, we can so-called do aggregation. Aggregation means we take all these inputs and feed everything to one output, and then go security probe. That's the very typical application, okay, called aggregation. And as we said, it's a hardware device that is built for that. Okay. Other thing is, maybe you have two security probes. Maybe you have 2, 3, 4, 5 different security systems that need maybe different information, or maybe need the same information, but it's maybe too much for one analyzer. So you need to do so-called load balance. Load balance means some information goes to security probe number 1 and the rest goes to security probe number 2. So Yes, we can distribute the traffic as required. We can make copies of the information because maybe there's some new system is introduced and that should run in parallel. That is all can do by packet broker. Also, we can do filtering. Filtering meaning after a while, maybe you have seen all the traffic in your network, then becomes very clear that some traffic is even not needed at the security probe. We have seen, yes, every night there's backup traffic, and this backup traffic we don't want to analyze because we know it's well known, it's defined, not needed to be seen. And why this is important? I mean, very often this security probe, I mean, of course, this is also some item that is not for free. And maybe because of the filtering, you can save the cost on the security probe because we deliver less traffic and only relevant traffic to it. That's also packet broker. And what else is, for example, we have packet brokers, of course, they do deduplication. What means deduplication? Very often, particularly when you come with mirror traffic, or also can happen with tap traffic. So if you tap the information several times, you get several copies of the same packet. Of course, you can put this to security probe. That first of all will maybe overload security probe, but also sometimes maybe gives you wrong results because the security probe is maybe confused, gives you some false positives, for example. So we have machine, they find duplicates and they delete the duplicates. Okay, it's also possible. So they look into the packet and compare them and see this is unique, forward, it's not unique, it's a copy of something. Yes, then we delete that. Okay, so packet broker, in fact, what it does, it optimizes the traffic feed to the security probe. Yeah, because as we said, remember that aggregation example, if you have 20 links, is 40 ports from the top, so you need 40 ports on the analyzer. Yes, you can also have a machine like this one, take all the 40 inputs and only go out with one output, but that includes all the information, or 2 outputs or 3 outputs, depending, of course, on security probe. Okay, so this is also talking about deduplication that you see. Packets are several times present, so yeah, can delete the duplicates. So right, so this actually, let me just summarize here. And what we have seen is core requirement, and of course this is also for IT and telecom, but OT also very important to consider to have a reliable and a separate infrastructure. And very important is that doesn't impact production traffic. So that's again this point, when we talked about spam ports. Yes, spam ports sometimes really needed, absolutely must, but whenever you can avoid it, please avoid it. And what is the solution to that is, of course, tapping dedicated devices and also packet brokers that can deliver traffic to security sensors and probes. Right, Paul, I think I give it back to you, but I stop my screen. Right, here we
Great.
are.
Okay, thanks very much, Herbert. That was very, very interesting. I guess just to summarise, then, I mean, as you've seen from what Herbert discussed, and to summarise what's been discussed, a network visibility infrastructure based on network taps and network packet brokers can help to improve the security posture and the performance of those operational technology environments. And we do that because we're able to connect to those networks, observe all traffic crossing those networks. We're able then to filter out traffic that does not need to be analyzed, and we can aggregate traffic to reduce the cost of the network tools as well. And all of that combines to improve the security posture and the performance management of those environments that leads to improved business and organizational performance, improved worker safety, and also help to protect the environment as well. So that's everything we had planned to cover today. So I think now we're probably ready to go to the Q&A session. So I'll sort of throw it open to the floor for any questions or any comments that you would like to make.
Yeah, there is one question that was coming up. Is there any performance limitation on the tabs or on the network side, but also in the processing that they can do?
Thanks for the question. For a tab node, okay, the tab is completely packet loss free, so to say. So it cannot be overloaded. Okay, so that's the first thing, because it's physical device. So no, nothing can happen on a tab with a physical device, as we said. So right, this is the one thing. Yes, on the packet broker itself, the packet brokers you have seen, they are also designed like that. So they have backplane, of course, which is actually working packet loss free, meaning you can actually fully load the packet broker. That means sending several terabit of traffic to the packet broker and then also send it out again. So no, yes, it's packet loss free, just the opposite of a mirror session or span. I hope this answers the question.
Okay, and then there's a second one. Is there any limitation with integrating of existing OT security tools, like customer already has some OT tools which are currently running with spam ports, and now they are want to integrate also new ones, but also combine these somehow with a packet broker, for example?
Right, good, very good question. Yes, look, the good thing, the beauty about Cubro is, first of all, we don't care about the vendor of the security tool, first of all. So of course, we are good friends with everyone. Okay, right. No, this is completely vendor agnostic, so to say, because we, in fact, deliver only packets to the tool. So it doesn't matter if it's vendor A, B, or C. We deliver the packets to the tool. Okay, this is what it is. Sometimes we modify even packets because the vendor of the security tool cannot handle the data. Maybe there's some encapsulation on it. Maybe not so important for OT, let's say, but in other areas. So no, in fact, it doesn't matter. Yes, anytime the tab or the packet broker can be added. There is no problem. This is completely, it's just a packet forwarding we are doing. Okay, there is one alternative. Okay. Okay. Yeah, there's one good question. I think I have to read it, but I can do. OT networks often require low speed, like 10 meg or 100 meg. 100 meg, 100% correct. Because of high quantity needed, there is a pressure to offer low price tabs, often with more than one pair of tabs linked. What is the answer from Cubro to such question? Yes, it's a very good question. It's a very valid question. And the answer we have to that is actually we have specially developed a chassis solution. The chassis solution that actually in one of the chassis, you can tap up to 21 links. And I believe, of course, I believe it's price-wise very attractive. Okay. Right. So this is our answer to it, to have it actually some integration and for the rack space itself and also for the price. Okay, and there's another one. And how about if the tab loses electrical power? Would the data will be still processed? Yes, I mean, two things, of course. We said optical tab doesn't have any electrical power, so nothing can happen, so that's clear. But what about copper tab? No, copper tab. The copper tab is like this. If it's 10 or 100 megabit, then it doesn't matter. It will not lose any power. For gigabit, we are using the relay inside. And now this is a rather complicated question, to be honest. The very short answer is no, we are not losing data. This is the short answer. The little bit longer answer is it depends. that you maybe some milliseconds interruption could be, but it depends on the outside world. As we said, it depends on the switches that are used, things that we cannot influence. Okay, look, another one, due to the application feature, is there any impact on performance? Well, cool question. I like it. Look, this packet broker stuff, usually we do everything in hardware on an ASIC. Okay, so there's no limitation in performance. But when we talk about deduplication needs a kind of CPU, because you need to analyze the packet to see if this is duplicated. Yes, there is a limitation in performance, but the limitation depends on the box we are using. The smallest box we have is around 80 gigabit per second. Okay, so it can handle up to 80 gigabit per second. This is the smallest. Okay, but of course, when you add maybe a second CPU, when you add stronger CPUs, this goes up to several hundred gig. Okay. Will you offer FlexTap with just, good question also. So the question is, will you offer FlexTap? This is the FlexTap is the chassis solution for only 10 and 100 megabit. Yes, we do. It's already available. Yes, FlexTap, this module solution I showed you before, that allows you different cards to be inserted. There's a card for 1000 megabit, but we also have a card for 1000 gigabit. So it's available, yes.
Okay, I think that's probably all of the questions so far. I was just going to make a comment related to one of the earlier questions about sort of price pressure to offer low priced taps. Just the point I would make is that, again, typically you would see with Cubro products, actually across our range, our products are typically 30 to 50% lower cost of ownership compared to our major competitors, and that's for, if you like, carrier grade quality products. So for comparable competitive products, we're typically around about 30-50% cost of ownership, lower cost, both across network taps, network packet brokers, and in fact across our complete range of products. I haven't seen any other questions come in, so I think that's probably all of them. So I guess it just sort of remains to say thank you very much again for giving up some of your time for Cubro this morning. We appreciate your time. Hopefully it's been useful and interesting. Again, just point out there are some handouts, which is, I think, a copy of the slides and some other information. And we'll also be sending out a link for you to be able to get access to a copy of the recording today as well. So again, thanks very much. Obviously, if there's anything that you need or any information or questions that you have, please contact us directly and we'll do the best to answer you. Thanks again for your time.
Thank you.